Something is unfolding in the Alps right now that almost no one anticipated. A mountain long regarded as unchanging is beginning to split apart. A widening fissure is tearing through its summit. The entire southwest face is shifting bit by bit as if the mountain is trying to break away from its own spine. Sensors show acceleration. Evacuation plans stand ready. Experts warn the collapse could come suddenly with little or no warning. This isn't natural erosion, it is structural failure in motion, and it may be part of a much larger pattern emerging across the Alps. High above the valleys of Bavaria and Tyrol lies Hohlvogel, once considered solid and serene, but at its summit a wound has opened, one now impossible to ignore. The fissure stretches roughly 35 meters across the ridge. It gapes 6 meters wide, deep enough to swallow a person standing upright. What began years ago as a hairline crack has become a jagged, shifting canyon. Recent measurements show the fissure has doubled in width in under a decade. It is actively opening slowly but relentlessly, like a fault peeling apart. Experts estimate that 260,000 cubic meters of rock are now at risk of breaking free. That much mass would roar down the southwest face with the force of a runaway freight train the size of a skyscraper. And the path it would take is already mapped. If Hohlvogel's southwest flank collapses, the rock will plunge into the Hornbach Valley just across the Austrian border. The event would likely begin with a sudden fracture the moment internal tension finally overwhelms the mountain's ability to hold itself together. Then the slope would unravel. Massive blocks would tear loose, accelerating rapidly. Trees would snap like twigs. Trails would vanish in seconds. Anyone in the fall zone, hikers, workers, climbers, would have almost no chance to escape. Even though the region isn't densely populated, mountain huts, seasonal grazing areas, popular routes, and forestry stations all lie in potential danger. Any of them could be swallowed in the initial collapse or buried beneath the debris wave that follows. Because the mountain is actively moving, scientists have turned Hohlvogel into one of the most closely monitored peaks in Europe. To watch the crisis unfold, researchers from the Technical University of Munich and Germany's GFZ Geoscience Center have built a high-precision monitoring system called ALP Sense Bench. It forms a digital cage around the mountain, capturing every shift with extraordinary sensitivity. Laser scanners map the slope in 3D. Fissure meters record widening down to fractions of a millimeter. Geophones listen for tiny internal fractures. GPS stations track the mountain's movement around the clock. A full digital 3D twin simulates possible collapse scenarios. The system is so sensitive it can detect vibrations from wind rainfall, even nearby footsteps. If the fissure begins to accelerate, ALP Sense can detect that shift 2 to 3 days in advance. But the unsettling reality remains, even with this technology, scientists cannot predict the exact moment the mountain will fail. They can only watch the pattern build, like seeing a storm form, yet never knowing when lightning will strike. And despite these warnings, Hohlvogel has become a strange tourist magnet. Hikers and photographers walk right to the edge of the fissure. Some lean over it, some sit beside it, some take selfies with one foot on each side of the widening crack, unaware or unconcerned that the ground beneath them is slowly drifting apart. The mountain has become both a geological threat and a dangerous attraction, drawing people toward its weakest point. Younger forces of nature are accelerating the collapse. Each summer, meltwater from snow and ice pours into the fissure. Heavy rain saturates the cracks, reducing friction inside the rock. Sudden temperature swings freeze that water, expanding it and widening the fissure like a hydraulic wedge. These seasonal cycles act as natural prying tools, weakening the mountain from within. In the last 5 years alone, the fissure widened by 30 centimeters, small on paper, but enormous for a structure millions of years old. Nature is not just eroding the mountain, it is helping pry it open. That is when geologists point to the deeper truth: this rock was always vulnerable. Hohlvogel is made of Triassic main dolomite, a material known for a crucial property. It is incredibly strong until the moment it isn't. Dolomite does not bend under pressure, it fractures. Instead of deforming slowly like clay or granite, it silently stores stress and then releases it in sudden breaks. This means cracks don't creep, they leap. And once a fissure forms, the surrounding rock becomes even more fragile, setting the stage for cascading failures. Hohlvogel's southwest face has already collapsed multiple times. The last major event was in 1935, when thousands of cubic meters of rock tore free and thundered into the valley below. Then again in 2005, 2007, and 2016, each collapse revealed the same underlying instability, but none of them compare to what is happening now. The current fissure is deeper, wider, and far more structurally significant than any failure before it, and the Alps have shown how quickly a mountain can shift from monitored to collapsed. In the Swiss town of Brienz-Brunzowels, a slope long considered stable suddenly began accelerating. After years of moving just 1 centimeter per day, it jumped to 1 centimeter per hour. That tiny change, barely noticeable, was enough to trigger a massive collapse that forced the evacuation of an entire village. Hochvogel's sensors are watching for that exact shift, because once movement changes from slow to fast, collapse becomes unstoppable. If Hochvogel collapses, it may not be a single event. Geologists believe the failure could unfold in phases. A first major slide could destabilize everything around it. Additional collapses might follow weeks, months, or even years later. This would mean long-term closures of trails and summits, continuous monitoring, and major disruptions to tourism. Mountain huts and alpine businesses could face significant losses. For people living nearby, the mountain wouldn't fall once. It would become an ongoing hazard, an evolving threat hanging over the valleys. And the danger doesn't end with the initial rockfall. Once loosened debris fills the slope, rainwater can transform it into fast-moving mud flows. These flows could surge deeper into the Hinterbach Valley, damaging infrastructure and cutting off access routes. Unlike a rockfall, they are harder to predict and can occur days after the main event, triggered by nothing more than heavy rain. This is why regional planning has already begun. The aftermath could be as dangerous as the collapse itself. But Hochvogel is not alone. Across the Alps, similar warning signs are emerging. Instability is increasing. Rockfalls are becoming more frequent. Slopes are accelerating. New fissures are opening. Permafrost is melting. Lightning storms are intensifying. Extreme weather events have doubled in recent decades. Warmer summers melt the high-altitude permafrost, the natural cement binding mountains together. Heavier rainfall saturates unstable layers. Lightning fractures exposed ridges. The combination is turning once stable peaks into unpredictable structures. Hochvogel is simply the most striking example, a mountain allowing scientists to watch this transformation in real time. For the people who live near Hochvogel, the mountain was once a symbol of permanence. Now it inspires caution. Hikers move differently on nearby trails. Residents listen for distant rumbles echoing across the valley. Alpine guides check ALP sense data before choosing a route. The mountain feels alive in a way it never did before, not because it is erupting or shaking, but because it is changing day by day right in front of them. Hochvogel's widening fissure is a reminder that even the oldest landscapes are not fixed in time. They shift, they break, and sometimes they fail. As the crack expands and the mountain strains against itself, one question becomes impossible to ignore. When Hochvogel finally lets go, how much of the mountain will fall? Do you think the Alps are entering a new era of instability, or is this just natural geological cycling? Share your thoughts below. Every comment helps shape the conversation.